Okay, excellent. Yeah. Well, at least. Okay, now the recording has started, and now, yes, we are talking about datagram sockets class. Yeah. So yes, one option is to, well, basically, for the UDP protocol to work, for the datagram-based communication to work, you need to take into account, you really need to take into account the fact that these messages, yes, there is a chance, a non-negligible chance, really non-negligible chance that these messages might not ever arrive. So that is why UDP is not really that suitable for a bidirectional dialogue, if you will. It is mostly suitable for one side feeding the other side with data. One side feeding it with data. Now the other side can also send it data, but with something that is that keeps coming. So, but if there are single messages for the arrival of which you need to be certain, then UDP might not be the best protocol for you. So imagine, for example, that the server just has a very simple task. There is a, I don't know, there is a game that needs to be broadcast. It's a TV series. It is something that needs to be broadcast to a lot of people. So you just keep sending the UDPs to everyone. So you keep sending the datagrams to all the clients that are connected. And it doesn't really matter if some of the datagrams don't arrive, because you're not expecting anything in return. The feedback isn't really that important from the clients. Now, that is the ideal scenario for using the UDP protocol. So that is why if the dialogue between the server and the client, I sent you this, you sent me that, I need your response so that I can tell you this. If that is important, if that's what you want to establish, then UDP is a really, really bad choice for that. You should go with TCP. Yeah. So most of the time, UDP is used for unidirectional communication, a server that just sends data to the clients. That is ideal. That is ideal for datagrams. Okay. Yes. Exchanging datagrams. Let's look at the details from receive from and send to. The receive from and send to system calls receive and send datagrams on a datagram socket. Let's look at the other parameters. So receive from and send to, very, very similar. The arguments have the same meanings, approximately. The first three arguments to these system calls have the same meanings as in read and write. So we can see that the first argument is the socket, well, obviously, that we're going to use for communication, the file descriptor. The second one is the buffer that actually contains the message that we want to send. The length of the message, well, the flags, you know, for permissions, etc., blocking, non-blocking, if you want the call to be non-blocking by any chance. But still, that doesn't solve your problem. And of course, we have a struct socadre and soclen, which contains respectively the address of the destination and the length of that address. Yep. Okay. Now, at this point, things will get a bit complicated, very slightly complicated, because you can also use connect with datagram sockets. Now, at this point, you might say, Hocam, sen ne diyorsun? You said that there are no connections with datagram sockets, and now you're telling us that we can use connect with datagram sockets? What is going on? It is not what you think. This is not a connection using the UDP protocol. This is just abuse of terminology, abuse of a system call, if you will. Now, even though datagram sockets are connectionless, and they are connectionless, the connect system call serves a purpose when applied to datagram sockets. Now, what kind of a purpose? Calling connect on a datagram socket causes the kernel to record a particular address as this socket's peer. The term connected datagram socket is applied to such a socket. The term unconnected datagram socket is applied to a datagram socket on which connect has not been called. The whole idea here, I mean, this is rarely of any use, but the whole idea with using connect is that you will not have to extract the sender's address from a datagram in order to respond to them. If you don't use connect, you are receiving mail, you check the envelope, you look at the sender's address, Alp sent me a message, sent me a mail. Okay, I will respond to Alp using the address that he has written on the envelope. Okay, now that takes some time. It is not very practical. If, on the other hand, I use connect, that means the kernel will do that in my place. Do what? The kernel will record someplace in kernel memory where from Mr. Alp sent me his mail. And when I want to respond to him, he will use that destination address automatically. That's all there is. So it doesn't change anything in UDP as far as communication is concerned. It is still unreliable. It is still using the mail logic. The only thing that changes, it saves us from having to read from the envelope the sender's address, to write it at a new envelope, and so on. It facilitates a bit the practical part of the communication, but it doesn't change anything in principle. So you can forget about this, even if you want to. After the datagram socket has been connected, well, what are the differences? Datagrams can be sent through the socket using write and send, instead of using receive from and send to. Using write and using, of course, read in order to read them. The effect of connect is asymmetric for datagram sockets. The above statements apply only to the socket on which connect has been called, not to the remote socket to which it is connected, unless a peer application also calls connect on the socket. So the only advantage is basically that it will allow you to use write and read instead of having to deal with send to and receive from, and having to deal with putting the address of the destination every time into the function calls and so on. So it is only for practical purposes. Changes nothing in principle using connect. Summary, well, basically we're at the end. The whole idea is what? The domains. What is of importance? Two domains of importance: AF Unix, AF INET. The AF Unix domain, in order to create sockets between processes that will communicate on the same machine. AF INET domain, in order to create sockets that will communicate across machines. Two types of sockets for each domain: stream sockets, datagram sockets. Stream sockets for reliable connection-based communication, datagram sockets for unreliable but live mail-based, datagram-based communication. Why use sockets when you have shared memory, when you have pipes, when you have, I don't know, message queues, when you have FIFOs? Sockets are practical to use. You can use the read-write system calls, not having to worry about, as in shared memory, where you wrote something, etc. You don't have to worry about allocating shared memory, etc. It doesn't have the limitation of pipes, which is to only communicate between parent and child processes. So you can use sockets between any two processes, like FIFOs. And also similarly to FIFOs, sockets provide intrinsic, inherent synchronization. If there isn't anything to read, it blocks on its own. You don't have to worry about condition variables or semaphores. But additional to FIFOs, sockets also allow you to communicate across machines. That's the whole idea. That's the whole summary of what is going on with sockets. Now, to give you a small example, now I'm not going to get into the C part of it because you already have examples, just to show you what is going on in Java. Now, these are the things that we talked about in POSIX. This is C. This is the same stuff since the 1950s and 60s. Nothing has changed. Well, very little has changed since then. Now, let's look at what a contemporary Çağdaş, a contemporary language, uses, how it uses these principles in order to communicate across machines. Now, here we have a TCP server written in Java. As you will see, there is no listen, there is no bind. There is just what? In the public static main. It creates a server socket. So basically, it's not a socket, but a server socket. So already the class contains the information that this is a socket that will be used for binding and listening. So it has integrated that information inside the constructor of that class. So we still have socket, listen, and bind, but all three of them have been put to the constructor of server socket. And all I have to do is just give it the port number. Well, it has given it the port number. There is no need to give it the IP address because it is using some default value, probably localhost. And then the server, in an infinite loop, so while true, do what? Just accept a new connection. So every time that accept returns, it creates a copy, just like in POSIX, a copy, a new object. So this is another server socket, but this is a socket. This is object 1, this is object 2. It creates a new object, a copy, just like POSIX dictates. And then it can use that socket as a file descriptor. You can put it to print writer, you can put it into a buffered reader, you can use it in whichever way you want to use it. And once you are done, all you have to do is just call socket close in case there is an exception or anything, and then you're out of it. The client is even simpler. All you have to do is just call new socket, and everything is inside it. Socket plus connect. So here is the address to connect to, here is the port number, and that's it. It returns a file descriptor, and you can use it with the buffered reader, input stream reader, whatever you want to. As simple as that. The same idea is true also in the Python and .NET. But even though it appears as simple, even though someone would, an amateur would say, oh, this is way simpler than POSIX. It is using a much simpler protocol. No, it isn't doing anything simpler. It is still using the same ideas. It is still calling socket listen and bind. I mean, it has to tell the kernel with which address and port to bind the socket. It is just simplifying the interface. It is just wrapping up those ideas of POSIX with a simpler interface so that it will be more user-friendly and easier for the developers to manipulate and to use. It is just reducing the complexity, that's all. So the most complex form of it is the form that you see in C. That is as complex as socket programming can get, and still it is not really that complex. You just have to follow the steps, and you're okay, you're covered. Yep. Okay, so now if you have any questions, now is the time to ask. Yes, Mr. Usnu.
Sir, you recommended to us while we are listening for request, as soon as we get the request, we delegate it to another thread. In this example, this is not accomplished.
Yes, that example was not a threaded socket. Sorry, a threaded server. It wasn't a threaded server. In a threaded server, what you do is, well, I also have an example of that. I think it's here somewhere. Thread pool server. Yeah, I have a thread pool server. So the thread pool server doesn't really do much. Server stop, etc. Thread pool server. Now, of course, there are many ways of implementing this. This is just one way of doing it. In a thread pool server, what do we see here? We see that in public void run, thread current thread, open server socket, etc., etc. Here it accepts a new connection. It creates a copy. So this is a copy, the new client socket. And somewhere it will give it, here it is. And then it gives the new client socket to the thread pool, to a thread to execute it. In fact, he creates the new thread in real time in order to handle this connection. So this is not a, this is a thread pool which creates new workers in real time instead of using the existing ones. But the main idea with the threaded server, or you can have it even as a base in the basis of processes. The main idea is that as soon as you accept a connection, you create either a new child process to handle that connection, or you create a new thread, or you give it to an existing thread or child process to handle it. You give it as a, I don't know, as a function parameter, for instance, to the thread. There you go. Here is the new client socket, the new socket that has just been created as a result of this connection. Go, talk to that person, do whatever you have to do. And what does the server do in the meantime? It immediately returns to the beginning of the loop and wait for a new connection. That's the whole idea. Oh, sorry.
A question from me, sir.
Yes.
So since the system call accept creates a new socket every time, I'm assuming because Java has a garbage collector, this is not a problem. Like destroying these new sockets is not a problem. But what's the case in C? Like, do we have to do it manually? Because the sockets are created by the kernel. We don't even know what they're called.
Now, Mr. Alp, where was it? So let's say that the server calls accept succeeds, and it returns what? It returns a file descriptor for the new socket. Now that file descriptor, where does it live? Does it live in the heap? No, it doesn't. It wasn't allocated from your heap. It is just a local variable in your function.
Okay.
So you don't have to worry about it. It's just a local variable. So as soon as you get out of the scope of that function, it is over. But since this is a server and it will keep on running in that loop, and every time that you create and every time that you accept a new connection, you're basically overwriting the old one. Unless, of course, you took that socket, that file descriptor, and gave it to a thread to operate with it. So in that case, it is still a local variable.
Okay, I see.
Any other questions, class? I know that this might seem a bit daunting at first. It might seem a bit, I don't know, might seem a bit scary. I don't know. I was scared when I saw this stuff for the first time in C. I was like, what is going on? Why listen? Why bind? Who is doing what, etc., etc. But as soon as I studied a few examples of servers and clients, it became all very clear. But of course, the best way of understanding this stuff, as with everything else, is to actually implement it, is to actually code it. Now, if you have no further questions, in that case, I'm switching to the final exam, which should be somewhere around here. Yeah. Now, class, did you get a chance to read it? Should we read it together? Let's read it together. I mean, we have time. If you have any questions, please feel free to ask whenever you want. Okay, so sockets and threads. Now, of course, here is a reminder, so please pay attention to that. Now, the objective is to write two programs. In this final project, you are expected to write two programs. One is a client and one is a server. The server is a database server. It's supposed to be a database server. And the client will basically simply just read from a file SQL queries, valid SQL queries, open up a stream socket to the server, and send those SQL queries to the server. Now, you might have 3 instances of clients or 5 instances of clients. This will be determined by the IDs. Where are the IDs? By the IDs that are inside the file containing those queries. So you will have a file containing these queries, such as, for instance, this one. Now, the first number in each row represents the ID of the client. So if, for instance, in this file, you see that you have 1s and 2s and 3s and 4s and, I don't know, 5s, that means there will be at least 5 clients. There need to be at least 5 clients. And of course, each client, for instance, in this example, client number 1 has at least 3 queries to execute. So you can have a file with, I don't know, 20 queries maybe, 3 for client 1, 5 for client 2, 7 for client 3, and so on. So you start reading the file from top to bottom. You read the first row. Okay, this is a query that needs to be executed by client 1. So client 1 will read it and send it to the server and wait for the response. This is a row that will be read by client 2, who will read it. He will see that there is his ID and send that query to the server, who will execute it on his database and return the response to the client. Now, I have given you the source from where you can find CSV files that will represent the database. And I have given you some examples of SQL queries. Now, of course, I'm not expecting you naturally to implement all of the SQL commands, just two commands in very simple forms: select and update. For those of you who are not familiar with these queries, I suggest that you go into just go into Google and type SQL. You will see the courses that they have there. For instance, let's go here and type SQL, SQL tutorial. And from here, if you study select and select distinct, as well as update, you will see that there are very easy commands. Those of you who are not familiar with them, the idea is very simple. So you basically select star from customers, basically just brings you all the records from the table named customers. Select distinct, the only difference between select and select distinct is that it will bring non-duplicate results. And update is used in order to update a certain record. So one is for reading and one is for writing. That is what's important. And I also simplified the commands as much as possible. So select will support single or multiple columns. Select distinct, of course, only for non-duplicate reading, and update with a single equality condition. So bring me the records from that table where this column is equal to this. That's it. Nothing more complicated than that. Because otherwise we can use SQL in order to form inner joins, outer joins, etc., etc. I don't want to get into that stuff. This is not a database course. This is system programming. I'm more interested on how you're going to implement the communication and synchronization between the database server and the client. Did you get a chance to study it? Any questions about what is going on?
That's a very cool homework, I gotta say.
A cool homework. I'm not sure that you will be thinking that way after having spent some time on it.
Probably, okay.
Yeah. Yeah. So the server, well, the server just needs the necessary stuff. It needs a port that it will use to listen for connections, a path to a log file. So since it is a daemon, it will not print anything on screen. The server will write everything to a file, output, errors, everything. It has to be a daemon so that you need to take measures so that the server will not be run twice. So if somebody tries to run it twice, it must be impossible to run it twice. So take some precautions against it. Read online how to stop double instantiation. This is an important skill. It will have a pool of threads, at least with 2 threads inside it, no upper limit. And of course, the path for the dataset, for the CSV file that it will use in order to create a dataset. The CSV file, now I have also kept it very simple. The CSV file will contain only one table, just one table. Just one table, a standard CSV. The first row contains the names of the columns, and the subsequent rows contain the data. That's it. All comma separated. So very easy delimitation. The server's main thread will just load the dataset into memory. It is completely up to you to decide how to represent the dataset. You use, I don't know, a hash table, a bidimensional array, a tree, a red-black tree, a linked list. It's up to you. I don't care. No, that's wrong. I care. I care that you justify your data structure selection. So if you use a red-black tree, tell me why. If you use a hash table, well, I want you to explain why you selected the hash table. But that's not really that important since this is not a data structures course. Now the server, after having created the database, it will create a pool of threads. The number of threads in the pool has been given as a command line argument. Those threads will be ready to handle connections. And the main thread, after creating the pool, it will wait for a connection. As soon as a connection arrives, it will select. Well, it will select. Well, not select. It will forward it. It will not actively select it. It will forward the connection to a thread that is not busy. So this is a time to use a condition variable. If, however, there are no threads that are available, well, in that case, the server will have to wait. So another case for a condition variable. So plan your synchronization carefully. There are many mutexes and condition variables around. The server process will only exit when it receives a SIGINT signal from somewhere else. So there is no terminal in order to type Control-C. Now, the threads in the pools, all of them will execute the same function. They will all have the same function. They will all be working in an endless loop. We will not be creating new threads. Whatever threads we are going to use, they were created at the beginning of the server. We are not going to create any new threads. So if we have 2, we have 2. If we have 8, we have 8. That's it. And each of them, they execute the same function, and they wait for a job to be given to them, or they wait for a signal from the main thread that a job is available. How you do that? That's up to you. If there is a job available, so a connection available to handle, they will take it and handle the connection. Once the connection has been handled, they will return to the beginning of the loop and wait for a new job. How do you handle the connection? Now, a connection is simply just a client sending an SQL query. Okay. So the connected client will send a single SQL query, just one, not 2, 3, just one. It will send a single query through the socket. The pool thread will parse it, figure it out, execute it, calculate the result from the data set. So if it wants to read something, it will say, there you go, this is a result. If it has conducted an update, then it will return the updated records. These are the records that you have updated. And it will additionally sleep for 0.5 seconds because since your data set is very small, these things will happen very, very fast. So it will also sleep for half a second to give the impression that it is doing something, something difficult, something time consuming. The only two commands to be supported are select and update, one for reading, one for writing. Now we have one for reading and one for writing, which means that this is the readers writers paradigm. This is a very important paradigm. So if the query is a select, that means we have to read. That means there can be multiple threads that can read at the same time. Just because one thread is reading from the dataset doesn't mean that all the other threads reading from it have to stop. No, they can all read at the same time. So this is a shared lock mechanism. So you have to implement a shared lock. We have seen it in class, how to implement a shared lock. But if there is a query with an update in it, so that means somebody wants to write to the dataset, well, that means that thread needs an exclusive lock. An exclusive lock means that only that thread must have access to the dataset at that given time slot, and everybody else must wait. So more condition variables. However, after processing the first query, which is a select, the second query might be an update. So a thread that was a reader now has to become a writer. Or after an update, there might be a select. So after being a writer, now a thread might need to become a reader. So the roles will be changing at each new query arriving from the client socket. So be careful with that, how you implement it. Yeah. Hüsnü Bey, sorun var.
Hocam şey soracaktım. Bu shared lock ve exclusive lock implement etmemiz gerekiyor dediniz ya. Burada flock sistem çağrısını shared lock ve exclusive lock flagiyle.
Flock'la işimiz yok burada. Flock'la burada işimiz yok. Burada reader writer paradigm var. Flock'la hiçbir işimiz yok burada.
CSV file iyileşirken
I am not expecting you to use file locks here in any way. I am expecting you to solve this using condition variables in mutexes. We had talked about shared locks and exclusive locks, if you remember, while we were talking about readers and writers. Okay, let me make this even simpler. Readers, as we implemented them, they represent shared locks. The writers, they represent exclusive locks.
Tamam hocam. Ben tekrar bir bakayım ona.
Peki. Or you can forget about locks. Just make sure that the thread behaves sometimes as a reader and sometimes as a writer. That's it. You can forget about the locks. Let's not confuse it with locks. I should definitely include it in there. This part is not supposed to be solved with file logs. No. In fact, don't use file logs. Don't use file logs for this part. Please don't.
Okay.
I will make it explicit. I will add it in now in the version 2. In fact, I should include it right now. Version 2. Stay away from file logs. Okay, so here we have an example of the output of the server. So basically just threads that are waiting for a connection. A connection has been delegated to thread ID number 5. This is a query, and the query has been completed. 12 records have been returned. That's it. And on the side of the client, this is the query that he sends, and 5 records have arrived, and these are the records that have arrived. That's it.
Sorry, could you repeat the stopping mechanism of the server process again?
The server only stops when it receives a SIGINT signal.
But you also said there is no terminal to press Ctrl+C.
But the terminal is not the only way of sending a signal to a process, right?
Okay.
You can
Okay.
also use the kill command.
Sure. Yeah, yeah. I see now.
Okay. Any other questions?
Sir, should we send the kill signal from terminal additionally after we have done testing, or one of our processes should send it, or one thread should send the kill signal to the server?
No, no. I mean, we will be killing the processes. You don't have to kill them. So the programs that you will write have to run indefinitely. The server must run indefinitely.
Okay. Yes, kill signal will be sent the outside of the
We will be
program.
sending the kill signal when we are testing your program.
Okay, I get it.
Okay,
Thank you.
welcome. Any other questions, class? Now, the major difficulty, I mean, the sockets and everything is not really that difficult. Sending something to the threads, having the threads rate with condition variables, that part is also easy. Just pay attention to the to handling a connection. So a connection is given to a thread in the pool. The thread, as soon as it arrives, it checks the connection. So is it a reading connection? So does it want to read with this query, or does it want to write with this query? If it wants to read with this query, the thread behaves like a reader. If it wants to write with this query, then it behaves like a writer. It executes what it needs to execute. Then it reads again from the same connection. If there are more queries coming up from the client, and very probably there will be, then it checks again. Is this a reading command? Then I will behave as a reader. Is this a writing command, an update? Then I will behave as a writer. So it is expected to exchange roles, to change roles, the thread, depending on the query that has arrived. That is what I mean acquiring a shared log or an exclusive log. If it behaves like a reader, that means it is acquiring a shared log. If it behaves like a writer, it will be acquiring an exclusive log. This has nothing to do with flog. I will write that in the in version number 2. I have given you all the help that I could have given you. If you have any questions, feel free to ask. Now is the time, because I will not be answering any questions about the final project after this, unless it is very critical through Moodle for clarification purposes. Well, okay, class. I mean, in that case, I'm assuming that everything is clear. So we still have a few minutes. Take your time, study it, and let me know. Otherwise, we will stop in a few minutes.
I mean, it seems clear, but we never know what happens while doing the.
Of course, that is true. That is why you can always ask for clarification. Sorry, you can always ask for clarifications through Moodle. That is open.
Okay, sir.
Sir, I didn't understand. There is no terminal, you said.
Yes, that is true. The server is a daemon, so that means it must not be associated with any controlling terminals. So after it is executed, it will return to the command line. That's it. So it will run in the background. We had a lecture specifically on this, the lecture on daemons, where I explained to you how exactly to create a program with no controlling terminals. I even gave you example code for that. It is also available on your textbook. Remember, we had to do 2 forks to achieve that. And we're also calling some other stuff. Okay, class. Well, that's all from me. That's all for this semester. I'm stopping the recording.